In this video, we're going to do some practice problems together. Please make sure you try them yourself first and then check your answers by unpausing the video. So we're going to use the naming rules that we learned in the previous video to name the compound shown here. And practice will just make you better and better. So let's start with this first one here. A, we notice there's only 2 carbons. There's no substituents. It's all just H's. And there's no double bond or triple bond. It's just an alkane. So we have 2 carbons here. It's an alkane. We have eth for our 2 carbons, ane, ethane. That's it. So let's go to our next one, B. See, some of them are so quick, right? The other one, the ones that are tricky have substituents on them, but eventually those become quick as well. Look, nice straight chain carbon here, carbon chain here. There's no substituents on it. Looks nice and easy to name. Let's just count our carbons properly. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's known nane. Because it's an alkane, no double bonds, no triple bonds. All right, now we do have substituents in this situation. We do have to find a parent chain. So let's go ahead and try that out. We could go this way. 1, 2, 3, 4, 5, 6. That's possible. We could go this way. 1, 2, 3, 4, 5, 6, 7. So it looks like 7 is probably my longest chain. Yeah, I think 7 is going to be. So 7 is our parent chain. So 1, 2, 3, 4, 5, 6, 7. So that's a heptane chain. Our substituents are located here and here. And so we have to do some counting. I'll start counting from here. 1, 2, 3, 4, 5, 6, 7. If I do that, my substituents are at positions 3 and 4. If I started counting from, let's say, the other direction, so let's say here, 1, 2, 3, 4, 5, 6, 7, then my substituents would have been at 4 and 5. And so at the first point of difference, the red direction wins. So we're going to go with the red numbering. So now that we have that, there's 2 methyls. Keep that in mind. We have 3, 4 hyphen dimethyl because there's 2 methyls. And then 1, 2, 3, 4, 5, 6, 7 heptane for a parent chain. 3, 4 dimethyl heptane. So a little bit more complicated because you have to find the parent chain and then number the substituents, but it becomes very repetitive after a while. So that was example C. Let's do another easy one before we go into the more complex one. Let's do example D over here. We have 1, 2, 3, 4 carbons. The only tricky part here is you do have to make sure it's an alkane. You have to make sure you have the right number of H's to make this an alkane. So we know if there's 4 carbons, there should be, if it's an alkane, H2N plus 2. So 2N is 8, so 10. It should be 10 hydrogens. So 3 plus 2 plus 2, that's 10 hydrogens. So that does make this an alkane. There's single bonds in there. If you want to just convert this to a structural formula to check. So 3 H's on the first C, 2 H's on the second C, 2 on the third, and then 3 on the last one there. So we're good there. That is an alkane indeed. We have 4 carbons, no substituents, which is nice. So we're dealing with a butane alkane molecule. All right, let's go and try one where there are substituents this time, and we need to find the longest chain. So we'll try example E over here. There's so many different ways you could start counting here. This looks like a good way to go. 1, 2, 3, 4, 5, 6, 7. That's possible. I'm just going to really try to select the longest looking ones to me. So maybe this one here. So this way and down here. That's 1, 2, 3, 4, 5, 6. No, not that way, because that red one's even shorter than the 7. So as soon as I see one is shorter, I can just kind of eliminate that process. Maybe this way. That'd be 1, 2, 3, 4. No, that would be just wrong. Maybe this way. 1, 2, 3, 4, 5, 6. So nope, not that one either. I could have gone this way. It would have given me the same thing as the blue one, because they're the same thing, just kind of flipped. So I think the one I have highlighted is the best option right now. So that's a 1, 2, 3, 4, 5, 6, 7. That's a heptane chain because there's 7, and it's an alkane, so it's a heptane chain. I have substituents. A lot of them have here, here, here. So I have these methyls. I have 3 of them. Methyl here, methyl here. And then this one here is a 2, so it's an ethyl. So here we have to number these to get the lowest possible substituents. I'm going to go in different directions just to see what our possibilities are. So we can go this way, 1, 2, 3, 4, 5, 6, 7. When we do that, our substituents end up being 3, 4, and 6. 3, 4, and 6. We could have numbered the other direction instead, where we had 1, 2, 3, 4, 5, 6, 7. If we do that, we get 2, 3. Oh, I think I missed one. We have 4 substituents. Let me go back and redo that. So green is 3, 4, 5, and 6, whereas that pink color is 2, 3, 4, and 5. So at that first point of difference, pink wins. So pink is the right way to go from right to left. So we're going to go from right to left over here. So we'll start with our ethyl group first, because that's in alphabetical order. Ethyl is at position 4. So we have 4 ethyl. Then our methyls, we have 3. So we have 2, 3, 5. 2, 3, 5. Trimethyl. And then heptane. So that was a few sample problems for naming alkanes from their images. In the next video, we're going to try the remaining ones. But for now, make sure you've mastered the ones that we just did here. And you understand all those basic rules. And in the next video, we'll take up the next few molecules.